Example 1, given an initial investment of $12,500 at an APR. APR means annual percentage rate, and that's our rate, of 9%, which is continuously compounding. How long will my $12,500 take to double? And then what would be your amount in 15 years? Now, okay, someone mentioned this earlier. If it says continuously compounding, what do we use? A person. Okay? So, but we have two questions here. We have how long will it take to double, which I'll do on the left side here. This is our double. And then, what is their amount in 15 years? Okay, I'll do this on the right side. Okay, there's really two questions. This is 15 years. I'll do the 15 years first because that is simple. They want to know the amount. So they want to know our A, which means all I do is fill in my variables here in the calculator and hit enter. That's nice. So what does my p-value represent? That's 12,500, which is our initial amount, right? So we have 12,500. Let's not forget that E is actually a number in the calculator. It's not a variable. We don't have to find a value for E. Right? What's my R? It's my rate, 9%. Do I throw it in as 9? No, it needs to be a decimal. What's the decimal version of that? 0.09. So 0.09 times my time. What is my time here? 15 years. And what did some of you guys get? That sounds about right. Just type this in the calculator. 12,500. E is above ln in blue. So I hit the blue button, then ln. And it already puts the exponent there for me. 2.718, but it goes on forever like that. And then for my exponent, it's 0.09 times 15, right? I mean, that is it. That is it. So, we have this decimal, and it's money, so what am I rounding to? The hundredths, which is the second decimal, right? It's supposed to be 48,217 and what? And 82 cents. That's it. Man, I love when they give you a problem like that. You just put it in the calculator and answer. It's a little bit more work. I still love it. Okay. It's a little bit more work when you got to solve for the exponent. But in a case like this, I love it because you guys should be able to do it easily. Okay, when you need to find the end amount, the A value, man, just put it in the calculator and enter. It's great. That's why I did that one first. This one, holy smokes. Okay, our initial value, they want to know how long it's going to take to double. That means if they want to know how long, we need to solve for t. We're going to solve for an exponent. Okay, so my p-value, I still start with 12,500. My rate is still 0.09, but I'm solving for t. Okay, what's it going to equal, the end amount? How do you know it's 25,000? Double. They want to know how long it's going to take my 12,500 to double. If I double it, I multiply times 2, it's 25,000. So I'll put 25,000 here. That's my double. Okay? Now, in order to bring an exponent down, I use logs, right? And in order to do that, I need to get that exponent with its base alone. So I need to get this exponent here with its base attached to just the E alone. So what do I got to get rid of on the right side? Yeah. Yes, yes, yes. Good. I need to divide by 12,500. Both sides. And without using your calculator, the right side is e to the 0.09t. What's the left side? 2. We just said 25,000 was double 12,500. So if I divide it, it's going to give me 2. 2. What do I do at this point? Which one, log or natural log? Why would I want to, I say sometimes you can use either, but I always tell you use natural log so there's no confusion. But why here would I want to use natural log? Yes, thank you very much. When I use natural log, it cancels with the e. Now, using log or natural log is a lot like dividing. You see how I divide both sides by 12,500? If I take the natural log of this side and the e natural log cancel, I have to take the natural log of this side. I still want my equation balanced. So now I've got the natural log of 2 equals 0.09 times t. The only thing that's left after canceling is my exponent. On the toilet. That's where everybody's supposed to be thinking in the toilet. I'm saying, okay, now how do I get t alone? Yeah, why don't I'll just divide by 0.09. Gone. T equals the output. I was going to rewrite it, but why waste good? I would say 8 for this. So what is, in your calculator, the output of 2 divided by 0.09? Be careful. You are not taking the natural log of 2 divided by 0.09. You're taking the natural log of 2 separately. Then dividing that value by 0.09. Okay, so when you put it in the calculator, make sure you do this the correct way. I always like to use my fraction because it separates it for me. So I'll say the ln of 2 on top divided by 0.09. What do we get? Yeah. So this is how long, this is in years. I don't know. If you're a banker, someone's going to say about how long is it going to take you, what are you going to tell them? Yeah, I'd say approximately 8 years, maybe just before 8 years, approximately 8 years. So if you're a banker, you're going to say approximately 8 years. Now, if the problem would have said in years, 1/10 of a year, you would say 7.7 years, but we're bankers, we're all professional people. What are our votes? That's good. It's good, it's not bad. All right? Not bad at all. But we can check that out. I can put this in the graphing calculator and see where it doubles. It'll probably be real close and right. So what was our equation? What was our equation here? Originally, where do we start? We started with this originally, didn't we? 25,000 equals it. So if I want to solve for t, I put one side into y1, the other side into y2, and I see where they cross. See where they cross. Let's do it. For, you know, poo-poos and giggles. Bam. Let me clear this out. 25,000. That equals 12,500 times e to the 0.09, and that's where my variable is, the t. We don't have a t as an x, but who cares? It's a variable. Huh? Oh, my Lord. That's a typo. Second insert. Good. Thank you very much. Yeah. She gets the job. So, careful. You should have. You should have said it. You didn't. Now look at. If I want to look at this window and say, I want to make it a 10 by 10 6. Insert is above delete in blue.
I know that.
Now, how come I can't see it?
Because you don't have the right window.
Yeah, I'm only 10 by 10. This is at 25,000, right? So let's go to my window and say, well, the x will start at 20,000 and go to 30,000. Oh, we don't want that. We want that for our y's. Our answer should be 7.7, right? Yeah. Now the dot, our answer is 7.7. That should be our x value, right? So let's go from, let's do this from 0 to 10 still. By once, and our y's will go from 20,000 as a minimum to 30,000, because it should cross at 25,000, right? In that straight line, you see what I'm saying? It will go by 5,000. Scrap that. There's our y's, 25,000, and here's where our other one should cross. It should cross around 7.7, right? Isn't that what we got? This right here should be approximately 7.7. How do I figure out the intersection? Seconds. Well, I can, but if I want to calculate something, let's calculate the intersection. Enter. 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 7.7. Look at our x value. 7.7. Beautiful. Yeah, you should have applaud. It's great. Good stuff. Approximately 8 years. Okay. So there's always little, I mean, when you have an equation, the two sides, you can graph them both and see where they intersect. You just might need to know where to find it. If you're looking at a 10 by 10 window, you wouldn't see that. You got to know, well, if I need to find out where it's going to be equal to 25,000, I better go where 25,000 is. Okay? All right, good. At table 2, how long will it take for your money to double an account, which is compounded monthly? What should jump out at me in this word problem? Monthly. When I see something that is not annual or continuous, what should I be thinking? There's a K value. I mean, that should be your thought process. There's a K value, and it is what? 12. Because how many times a year is it going to be compounded? Well, if it's monthly, it's 12 times a year. Once you know that, we are going to go with equals P times 1 plus R over K to the KT. We still have an initial value. We still have a rate and time. But now it's just K. Okay, these are all values that we're just plugging in. You want to know how long will it take for your money to double? Yeah, we're going to have to find time again. So we're going to have to use log or natural log. So, what do we have here? We still have 12,500 as our initial investment. 1 plus our rate is what now?
0.07.
Yeah, it's 7%, but we say 0.07 in our equation. Our K shows right. Anyway, it's 12 times, raised to the K value, which is 12, times T. We are trying to find T, because they're saying how long. How long for it to? So double. Then it's 25,000. Well, we still need to use log, which means I still need to peel everything away. When you use a log, I need the exponent what it's attached to. I get rid of that 12,500, right? Bang. And I know since 25,000 is double 12,500, when I divide them, I should get a 2. Now, did anyone put this in their calculator to see if you get a nice decimal, or did it go on forever? It goes on. So you got to use that. Good idea. All right. So I have 1 plus 0.07 over 12 to 12t. What do I have to do to bring that exponent down? Natural law. I mean, it's the same process over and over. But we have this parenthesis. Who cares? Who cares? So I'm going to take the natural log of this side and the natural log of this side. Okay? When I take the log of something, that brings my exponent down in front. So I've got the natural log of 2 equals, my exponent comes down in front, that's the whole purpose of logs, times the ln of 1 plus 0.07 over 12. Okay. I'm multiplying t by 2 things, right? What am I multiplying t by?
12.
Yeah. Look at this. I'm multiplying t times the natural log here of this, and I'm also multiplying it by 12. So guess what? Divide it by 12 and the natural log of 1 plus 0.07 over 12. Okay? When I do the one side, I have to do to the other side. It's the same thing except big deal. We've got this expression here that has, we're adding a fraction. Who cares? Type it in the calculator that way. Type it in the calculator that way. This, gone with this. This, gone with this. C equals. I'm going to type it up here. You guys type it in your calculator as well. All right? Clear. I'm going to start with a fraction. ln of 2 is on top. It's nice. On the bottom is 12. ln of 1 plus, oh, there's another fraction. Okay, so put another fraction in. Alpha y equals 0.07 over 12. Does that look correct? No, not yet. Yeah, I know. Yeah, bam. So, I mean, does that look correct? Looks correct to me. Anyone get an answer? 9.93. So what would you, if you're a banker, what are you telling them? About 10 years. That is approximately 9.93 years. We will call that 10 years. So let's take a look at this in the previous question. This is the same amount we started with, right? 12,500, right? And it took 10 years to double at 7% monthly. This one took 8 years to double, and it's compounded continuously at 9%. So if you have those two banks offering you the same thing for the same amount you're putting in, which bank would you go with? The first one, because your money will double faster, 2 years faster. So when you guys start making money, you got to make decisions. Hopefully the bank will do this for you. You don't got to remember these equations, but it's nice when you know them and the bank tries to draw fast. People, when it comes to money, do weird things. Okay, so here's where we get into the new stuff today. Okay, here's where we get into the new stuff today. All right. When you want to compare two banks and the investments you're going to put in there, you want to decide, well, I'm going to go with the banks that give me more money. That's natural. That's smart. Okay? That's known as annual percentage yield. APR is the rates. APY is the yield. Yield means what it's going to give to you over the course of a year. Okay? The percentage that it's going to increase over a year. It's not the percentage that the bank is giving you. It's going to be compounded, whatever. It's going to be that percentage of money that you're going to have at the end of the year. That increase. Right? If you start with $100 and you end up with 110, well, that's a 10% increase. That's going to give you the increase, not the. It might have been 5%, compounded quarterly, whatever, but you end up with 10 extra bucks. It takes that extra money and figures out that percentage increase. So yeah, I want to know where I'm going to get the biggest percentage increase on my money, and that's where my money's going. All right? Now, APY has this funky little thing here. 1 plus your rate over, and the K is still there because, hey, but it's compounded, not just annually, monthly, quarterly, it's always be there. Raised to the K minus 1. Again, if we have an assessment, I'll give all these to you. Okay. All right? Question, where's the T?
Well, it's only T is 1 year.
Thank you very much. It is annual, which means wouldn't T be 1? So if I multiplied K times T, which is 1, do I really need it? Every time you make this, comparison, you're comparing each account over 1 year. Which one's going to give you the most money? Guess what? If it gives you more money over 1 year, it's going to give you more money over 2 years, won't it? Give you more money over 3 years. So we really don't need a T anymore here. Oh, but what happens if it's compounded continuously? What happens if it's compounded continuously? That's much nicer and cleaner. E to the R minus 1. The e to the R literally replaces this right here. It becomes e to the R. I'm going to show you something. All right? Now, how do we get the e in there? Well, if it's compounded continuously, that's what we always use. Let's see something here. Ready? In your calculator, as K gets bigger and bigger, what is this value going to approach? This value right here. We're going to put this in the calculator, this 1 plus R over K, parentheses K. All right? And we're going to call the rate just 1, just to make it a number. We can make it any number. Let's just call it 1. We're going to see how we can replace E with this. You ready? Y equals, clear. And we've got, everybody okay? And what are we putting in there? What was it again? 1 plus 1 over K raised to the K, right? 1 plus 1 over, we don't have a K, we'll put an X there, raised to the X. that sound about right? If there were k's, the x's. Let's look at our window. Let's go to a standard 6x6. Boom. As x gets bigger and bigger, means as x goes this way, because x will reach infinity as it goes farther and farther to the right. Let's look at the table and see what it approaches, what value. Any guesses? No, what does the y value approach as x gets bigger and bigger? Okay, 2 point something. Let me go down as this gets bigger and bigger and bigger and bigger. Close, not quite. Let's start at 100. Let's look at our table. 2.7 something. It's going to keep on going up. 2.7. It's going to be 2.7 something, right? It looks like it's not changing. 2.7, 2.7, 2.7, 2.7. Any guesses on what it's going to approach? Let's change our table set. Let's go to 500. 2.715. It's going to go 2.71. Why do you say 2? What?
2.8.
Not 2.8. You know what it approaches? It approaches E. That's why you can put E in there. You don't have to memorize that. I just want to show that to you. Okay, because some people are like, wow, why do you put an E in there? Because when you do the math, that's what it approaches. But it's continuously. For infinity, forever. Goes up, it will approach E. That's why we're going to do that replacement. So there is logic behind it. You don't have to know it a lot of times. You just got to trust it. Now you know. All right? So, if it is compounded with some sort of K, even if it's annually, your K is 1, right? This. If it is compounded continuously, this. And whatever yield is higher, that's where you put your money. So, why don't you figure out now? You don't have to use this, and you don't have to use this. Okay? You just want to figure out the yield for each one of these bank accounts. Okay? Which means pays this. This is your rates. Compounded quarterly. Your K would be what? It's quarterly. 4. So if I want to find the yield, I'm just using this one. I'm just plugging that in and hitting enter. That'll give me what percent that yields. All right? Same thing. Go through these and figure out A to F, what the yield is going to be, and then tell me where you put your money. Obviously, which one is your biggest yield? That's it. Relevant stuff. All right?